Ever wondered how ancient Rome, a city of over 1 million people, managed to stay hydrated? How did they power their lavish bathhouses, ornate fountains, and even public toilets without modern technology? The answer lies in one of the greatest engineering marvels of the ancient world, the Roman aqueducts. These weren't just simple pipes. They were monumental structures, some stretching over 50 miles, that carried fresh water across valleys, through mountains, and into the heart of the bustling city. They are a testament to Roman ingenuity, a system so advanced that some parts are still in use today. Join me as we journey back in time to uncover the secrets behind these architectural wonders that literally shaped a civilization. How exactly did they pull it off? The secret wasn't brute force, but brilliant physics. The Romans understood gravity better than anyone. They meticulously surveyed the landscape to find a water source, like a spring or a river. It was at a higher elevation than the city. Then, they designed the aqueduct with a very slight, continuous downward slope. We're talking a drop of just a few inches for every 100 feet. This gentle gradient was the key. It allowed water to flow steadily and consistently, powered by nothing more than gravity itself, without moving too fast to erode the channel or too slow to stagnate. It was a delicate balancing act that required incredible precision over immense distances. Building these colossal water highways was a Herculean task. The process began with an army of surveyors, called grammatici, who used simple but effective tools. They had the chorobates, a long wooden level with a water channel, to ensure the perfect gradient. For sighting and alignment, they used a groma, a cross-shaped tool with plumb lines. Once the path was mapped, the real work began. Roman engineers preferred to build underground channels whenever possible, digging tunnels through hills and rock. This protected the water from contamination and kept it cool. These tunnels, often just big enough for a person to crawl through, were dug by hand with picks and shovels, a grueling, dangerous job. But what about valleys and plains? This is where the iconic postcard image of the Roman aqueduct comes to life. When the channel had to cross a low-lying area, engineers built those magnificent arched bridges. Think of the Pont du Gard in France, or the Aqueduct of Segovia in Spain. These weren't just for show. The arches were an incredibly strong and efficient way to support the weight of the water channel high above the ground, using the least amount of material. They constructed them using a combination of stone, brick, and a revolutionary new material, Roman concrete. This special concrete could even set underwater, making it perfect for building the foundations and piers of these massive structures. The Romans' secret weapon was opus cementitium, or Roman concrete. It wasn't like modern concrete. They mixed a volcanic ash called pozzolana with lime and rubble. This created a mortar that was incredibly strong and durable. When this mixture reacted with water, it formed crystals that interlocked and filled the gaps, making the structure increasingly solid over time. This is why so many Roman buildings, from the Colosseum to the Pantheon, and of course, the aqueducts, have survived for 2 millennia. This concrete was not only strong, but also waterproof, an essential quality for a channel designed to carry millions of gallons of water every single day. Once the water reached the edge of Rome, the journey wasn't over. It flowed into massive distribution tanks called castella aquae. These acted like modern water towers, holding the water and regulating its pressure. From these main tanks, a complex network of smaller lead and ceramic pipes branched out across the city. This system was hierarchical. The highest pipes supplied public fountains, ensuring that even the poorest citizens had access to clean drinking water. The middle pipes went to the public baths, a cornerstone of Roman social life. And the lowest pipes? They were reserved for private villas of the wealthy elite, who had to pay a special tax for the privilege of having running water piped directly into their homes. Maintaining this vast network was a full-time job. A dedicated workforce, the cura aquarum, was responsible for constant upkeep. They regularly patrolled the lines, looking for leaks or blockages. Special access shafts were built along the underground sections, allowing workers to descend and clean out sediment or make repairs. Calcium carbonate from the hard water would build up inside the channels, like plaque in an artery, and had to be chipped away. Broken sections of the arched bridges had to be repaired, and any contamination sources had to be eliminated. This relentless maintenance ensured that Rome's water supply was not only abundant, but also reliable and clean for centuries. The impact of the aqueducts on Roman life was profound. It was a game changer. Access to a constant supply of fresh water dramatically improved public health and sanitation. It allowed for the creation of extensive sewer systems, like the Cloaca Maxima, which flushed waste out of the city and reduced the spread of disease. It fueled the Roman love for bathing, turning bathhouses into bustling social centers for business, relaxation, and gossip. The aqueducts also powered flour mills and other industrial sites, contributing to the city's economic prosperity. Water became a symbol of Roman power and technological supremacy, a clear message to the world that Rome was the center of civilization. But what happened to them? With the decline and eventual fall of the Western Roman Empire in the 5th century AD, the complex systems began to fail. Without a central government to fund and organize the massive maintenance efforts, the aqueducts fell into disrepair. Barbarian invasions often targeted the aqueducts, cutting off the city's water supply as a tactic of war. The channels crumbled, got clogged, and were plundered for their building materials. Rome's population plummeted, and the once mighty city returned to relying on the Tiber River and local wells for its water, just as it had 1,000 years before. The golden age of water was over, yet the story doesn't end there. The legacy of Roman engineering endures. Many of the aqueduct's principles are still used in modern civil engineering. The enduring strength of their arches and the incredible durability of their concrete continue to inspire architects and builders today. Some aqueducts were even repaired and brought back into service during the Renaissance. And a few, like the Aqua Virgin in Rome, which feeds the famous Trevi fountain, still deliver water from the same ancient sources along parts of the original route. They stand as silent, majestic reminders of a time when engineers, armed with little more than logic and ingenuity, managed to make water flow uphill, metaphorically speaking, and build an empire that defied time. Thank you so much for watching. If you enjoyed this journey into the past, don't forget to like, subscribe, and hit that notification bell for more stories from history. See you next time.